Now for Ladybug, first I'm gonna make this bigger so you can see it better. You can have it in here, Ladybug. We install a few different tools like Dragonfly, and Honeybee, which we actually have a few. Honeybee Radiance, Honeybee Standard, and Honeybee Energy, which these are a lot more components, different tools, which with more specific task in mind. For this tutorial, I'm only gonna focus in this Ladybug panel. And when you make it smaller, just keep in mind that it's gonna shorten the name. Just use the first letters, Ladybug. And I'm just gonna make it so it gets on the side. And to start with, just bear in mind that Ladybug has a lot of tools. There's a lot of things to learn about what you can do for Ladybug, and there's not enough time for one tutorial. But you can always go to the web page, Ladybug tools, and plenty of information there. You can get a few examples as well. You just scroll until you get to Ladybug. You can do the same for all the different tools, and just keep scrolling. It will give you a little bit more data of what you can do with this panel in specific for Ladybug, and also some of the examples of possible things to do. So I really recommend you to go into this page and check a few of those examples. Okay, now going back into Grasshopper, like I say, I'm going to show you some of the basics, a few of the main components that you're going to need always, so you can start experimenting with the software, with the tools. So the first one that you're going to need is in here, import. It's actually quite well laid out for you to start with. So go to the left. You're going to need the first two components, so you're just going to drop those. Then I'm going to drop this one, which is by the name LB EPW map and LB download weather. So the LB EPW map is going to let you go into a web page that has a lot of information for the weather data. So the weather data, a lot of things to learn about that. You can also do some research into it. Recommend you to understand better what those EPW files are for. But to make it easy for Ladybug to learn, they have this map that lets you go directly into a web page to download the information. To use it, you just after you drop the LBPW map component right here, the second one, you're gonna need Boolean or, as you can see in here, is set to true to open the EPW map in the supported browser. Yeah, it's asking you for bool, type in Boolean. So it's just true or false. You can use the Boolean component, Boolean toggle, and this is really handy to have actually every now and then. That is just by double clicking the square is gonna switch between true and false. But I actually like to use this button, and what it does is that temporarily, or better, when you press the button, it's gonna be set to true. When you release the button, it's gonna be false. So I'm gonna connect that button in there. I'm gonna clean this up. Lid. And when you press the button, then after you connected it to the component for the EPW map, you click that button and it will take you to the web page. And in here, as you can see, you have the whole wall layout in this web page, and you can go anywhere in the world. And what it does is taking information from weather stations around the world. We're just gonna go to Perth. And I normally like to go into the airport. That they normally have a really good register of all the information. That's also why you normally find more information points into near to the airport. I'm going to pick this one, and then you have two options: download for from the original web page, or here. It might be a little bit hard to see in the recording, but it says copy to clipboard. And I'm just gonna click that one. You just need the link. So copy link to clipboard. You go back into Grasshopper, you create a panel. Go here into panel. Seems it got stuck. Close this web page really quickly. Let's close that one. Seems it's not working. Let's close this up. Try again. I'm just gonna open the file from 0. Open it up. Grasshopper. Drop. There you go. And back to the last thing that I had. And going back into this, after you go into the web page and you copy the link, you come here, you create a panel, double click, and just copy paste. Something to keep in mind though is that some of those links go to zip file, which is going to contain individually all of the files. And when you learn a little bit more of what the APW files are, which is a collection of files actually, you might be inclined to use this. For the sake of this exercise, I'm actually going to use a different one. Just going back into that page, path. And I'm going to select a different one. See what it gives me. Copy to clipboard, same process. Rhino, a panel, double click, and paste. And this one, as long as you don't see that zip, it should work quite well. Sometimes the links go down for some time, so you might have to try a few of those dots. But it's the same process. Just click and select clipped, copy to clipboard. Copy link to clipboard and just copy it in a panel. When you have the link, you go back into Ladybug. This time you're going to use the first component, that is LB download weather. And now, as you can see, it's asking for the URL. That's the one that you're going to connect. Excellent. After that, you don't need this, and I just prefer to delete it. Again, I like keeping things as clean as possible. And now, next step is gonna be to take all the information from that APW file. For that, you go to the next component in the list of import, that is LB import APW. And then you just match the names APW file to APW file. And with that, you have all the information from path, from that location that you got in the web page, into your Grasshopper. You can see it's a lot of information like location, drivable temperature, dew point temperature, and actually all of these terms, if you're not familiar with them, I actually recommend you to check what each one of these is. That a good understanding of all of this will help you out to understand and put your mind into what you want to do in the analysis for the project, for any project. Because each one of these tools is going to ask you for different information. Excellent. So next step is going to be how to bring all that information to the file, to this tower, to start connecting all the information. Then you're going to start looking at all of these panels, and it's quite well logically laid out. And for this, first I like to create a solar path, and which you can go visualize data. It's good to start I prefer to start visualizing the data and then try to go into the analysis tabs. The one that I just put in the canvas, in the Grasshopper canvas, is this LB, Ladybug sun path, just to see the sun as we usually do in 3D software. And with the Ladybug is a lot of matching the information from one side to another, which, as I have explained before, in Grasshopper is all about connecting data. So here we have location. Note I'm just gonna leave it by default, since we don't have actually a location not in here. But you can read and see it's just a number between minus 360 to 360. And it's gonna rotate what it says counterclockwise. So it's just giving the angle of rotation for that knob if you want to make it so something specific. Next is asking for HOYS, which is hour of years, I think it is. Let's find it out again, which I know is in here, HOY. Hour of the year, yes. So let's put this one just in here, analyze data. You have a few options to connect to that is HOY, which actually, for Ladybug, you can actually search for all the components. So you can actually type this, HOYS, and it will give you those Ladybug components. So you just type in HOY without the S actually, and it will give you those two. The one that I just put in here in the canvas is this one, same one. And that way, again, following what the information is asking you for and what it's gonna give you is just the month. It's just a number between 1 to 12. So we can create a slider 1 to 12. Plug that in, the same for the day, 1 to 31, and the same for an hour, which will go from 0 to 24, and minutes. You can leave it by default as well, not necessary to plug all of that. So I like to keep it up to the hour. So let's go to June 21st. Oh, sorry. This is June. This is 21st. And let's make it midday. Perfect. So again, you can plug in all the data. Here might not make any sense for you. So this might be not the best case to use the components, but just make sure that you're connecting the correct names. That's something different in Ladybug than the usual Grasshopper. The Ladybug is going to use their own information, their own way to read information. Like in this case, this number, the Ladybug component knows that the number goes in there. So for you, it's not about matching that number, but matching the names of the components. But still keep in mind that it's just that the people creating Ladybug is using their own numbers. They still follow the same logic, connecting data from left to right and making sure that the index plug in correctly. All right, next, just following again, deadline saving time. We don't really use that around here. It's all the time. Again, just something that we don't use in here. Center point, that's something that we actually use in here. And for that, I'm actually going to use the center point of the base of the rectangle. So I can go back here and I can take area and take this rectangle. So now I have that center point. That's going to be the center point of that sum path. Center point. Scale. This one is actually sometimes confusing to use, depending on the project. Sometimes have to be bigger, sometimes has to be smaller. Let's see if that's, yep, that's too big. So go really small. Zoom. Still huge. So I will have to go into 0.01. Oop. 0.0121. There you go. That's a better size. Click there, click outside, zoom. Perfect. Now you have the sound path, something that we're more used to deal with in 3D software. And now you can keep going into a few of these components. Some of those are not necessary, but it's good that you actually don't stop just because you can see it. It seems it's working. Don't stop. Just keep reading and see what else it's asking for. Maybe it's something that it will help you to do more specific things. But I know for now I'm not gonna use this. I'm gonna leave it in there. But now, actually, something extra that I like to do for this is that you can see this little X, that is the point where this hour is. So you can see when I change the hour, it's changing actually as it usually does, depending on the date. Let's move it here so you can see it. But looking at that X is not that easy. So what I'd like to do, and again, just go back into each one of those inputs and outputs and hover over the names and read slowly what the information that is giving you is, so you get a better understanding of what you're dealing with. Just for you to know, the report is actually empty. Is again something that Ladybug does, but nothing to worry about. If it doesn't have information, this is why you have to hover and read to know what it is that you're dealing with. And again, just this is more things that you might have heard, but you're not really familiar with it. But still, I recommend you to go read online a little bit more of information what azimuth, altitude, and all of this is. All of these weird names that you encounter, so you get a better idea of what you are dealing with, what information you're using. But yeah, going back into that dot, it's a little bit hard to see, so what I like to do is, because I know it's a dot and I can create a sphere from a dot, just bring the sphere, and the one that I want is the sun point, and just connect that here. And I'm gonna give it a radius, so let's see if one is might be too small. Let's make it 100. 100. There you go. Maybe even better, bigger. Let's make it 300 as maximum. Bigger. That's good. So I make it, let's see how, 150. Yeah, I like how it looks. For this component, because I'm not going to change that number, I just go here, internalize data, and it will put that 150 inside this. So if I hover that now, by default it's 150. Cool. Now if I move this HOY component numbers, you will be able to see how that is moving, which is the usual thing that you can find in software like Revit quite easily. But in here now you have all of these extra information vectors. It's actually going to be the vector line, a line between the point, the sun point, which is this sphere, and the center of the geometry of the point that you gave it to the component, which was here before, which it was the base of that rectangle. So it's always going to give you that vector, and you can actually visualize vectors. Just coming here to display a vector. This is going to be the anchor, this is going to be the vector. The anchor, I'm going to give it the sun point. And actually going to need to use a component that is called amplitude, which is going to take any vector and multiply the distance that it has. So I'm going to take that vector here, You can see here again, every time that you see an arrow, it's easy to think that it's going to be a vector, and that black and white arrow. And then the amplitude is just, I'm just going to multiply this by, let's make it something big. Might be too much. Now we connect this. It's actually quite well. And as you can see, it's going right into that point. Let's exaggerate this. 5,000. There you go. That's what the vectors is in here, which is a combination of the altitude and azimuth to find that vector. That's how it works. But you can use this individually as well. Altitude and azimuth is the horizontal vertical angles of the sun, and that's how it finds the position. That sometimes it comes really handy to have this information for really complex analysis. Now I'm gonna keep this just for you to visualize what the component, the SunPath component, is doing, because something really interesting that you can do is here we're using 1 day at a time, but you can actually have the option to plug multiple months, and you can do it as we've done before, creating a list of numbers. So let's say I want to have January 1, June and December as the month. And now if I plug that in, that's what you get. Let's make all of those 21st, and that is just where it goes. So now you have January, December, and June right at the end. And you can add as many numbers as you want, as long as definitely between the month numbers 1 to 12. And then you're gonna have all the vectors over the information of the sun hitting the building and those dates. Now you can start adding as well different days. Let's say you want the start of the month, the start of the month. So let's say I need to do a panel first. The first, something in the middle. Let's actually make it 21 and 30. Multiple lines, and if we connect that to day, just that you have more data, and you can keep adding things over and over. Here, it's actually a few that overlap quite closely, which is between January and December. But another component that you can use actually in Ladybug, if you come here to analyze data, is Ladybug analysis period. That is right next to the one that we're using so far, that is calculate over year. The analysis period is actually give you the option to be a little bit more precise about the month and days and hours that you use for an analysis. So you can plug in independently a start of the month, so you can do periods of times. So you have a start and end. So start of the month, end of the month, start of day, end of day, hour, and you have how many hours of those days you want to take. Quite handy to do if you want to do specific periods of times. Something that I definitely recommend you, and be really careful and mindful if you plug in too much information. If, for example, you do something crazy like put in from January to December and take every day and take every hour, you're gonna completely destroy your computer. You're gonna crash your computer and it's gonna keep trying to analyze all the information. That's too much information for normal computers to deal with. So for this analysis period, be really mindful. Start small, and then you can start going bigger and bigger in the period of time that you analyze. Okay, I'm actually going to use that component. let's move it back here. I use this one here. And I'm gonna do from, let's make it from, actually, let's 0 to 12. It's gonna be start of month, end of month. Let's make it 6. 6 June, and just 1 month. Something small again. Start small. Start of the day, 21st to, let's actually make it 21st to the 21st. And for the hours, I'm gonna take actually from 8 AM to 5 PM. Start of the hour and end of the hour. And this is important when you're dealing with hours. Again, doing all of the hours for each one of the days is gonna be quite a lot. So that's why they have the time step in here. So between 8 and 5 is, let's actually take every, let's make it small, every 5 hours. Actually make it 4. 4.5 will be in the middle. And if you connect a panel in period, it's actually give a good understanding of what you're taking. So we're going from June 21st to July 21st between 8 and 5. It takes these 24 hours numbers. So something to keep in mind, no AM or PM. So 17, and it taken at 4 hours. And here again, HOIS, HO-wise to HO-wise. I have to give you some time to run that analysis. And there you go. As you can see, it's a lot of information, even if with a period of time that is not that much. So be really careful. So let's make it something higher. 6. And this period of time for analysis is the one that you need to start doing some of the analysis options that you have here in analysis geometry. Just keep in mind, the more, the bigger the period of time, the more information that you're gonna have, so the more precise the results are gonna be. And then it comes to the capacity of the computer to analyze all of that information. So our usual computers, normal desktop and especially laptops, are not that powerful. So be really mindful of the amount of information that you give it to analyze. And start small, start really small. Now, you can see it's a lot of information to take in. Okay. Now for the analysis that we're going to use is the direction hours, which is here, analyze geometry. And it has a few options. You can experiment with them. It follows the same process as this one that I'm going to show you. It's just going to give you different results, but it normally ask you for the same type of information. And you just hover over it and read the information that it's asking you for and try to match the names with the names, and it will be easy to do. Okay, so here it's going to be asking for some vectors from the LB sound path. So plug in the vectors. Time step, a positive integer for the number of time step per hour at which the Ladybug sound path component generates some vectors. This is correctly interpreted the time duration represented by each of the input sum vectors. So 1 for 1 vector per hour. Let's make it something. How many vectors do we have? We have yeah, a lot of them. 1,700 vectors. As you can see, it's a lot of information that you can get from a short period of time. So I'm actually going to leave it by default, one per for one vector per hour. So just going to create 1,704 steps. The geometry that I want to analyze, you can read all the information to have a better understanding, but it's just to keep in mind the geometry that I want to present the information to, which is going to be these blocks, which are the rotating building that we created before. Now, context is simply extra geometry that you can have on the surroundings. And actually, for this analysis, sometimes like to create a basic rectangle as a base. I'm just creating a surface. I'm going to import that into Grasshopper using actually use a surface component. Set one surface. Now I'm going to use that as the context. So the difference is that it's not going to be as precise in the analysis as it is with the geometry. Geometry is going to be the main surfaces that you want to analyze, and the context is the surroundings, so it doesn't take too much time trying to analyze that. And I'm going to internalize that data, so I can delete it from Rhino. Give it that as a context. Grid size, this is an important one because it's going to be the resolution of the analysis that the component is going to do. So try to go big first and then try to go back. So I'm going to save this just in case. It is good to often click that save button because when you're dealing with the Ladybug, as you can see, there's a lot of information going from one component to another. And if you give it too much and your computer cannot handle it, it will crash and you will have to close and restart Rhino and Grasshopper. So save often before you connect anything. Save often. So the resolution is basically you can have a rough idea by taking the area of each one of these geometries that you're analyzing. So I know that that rectangle is, let's actually make it something like 800. It's going to take some time to analyze, to move all the information through all of the components. That's something to keep in mind. Every time that you now change a variable, it's going to move that change through each one of the components, and it will take some time to load everything because it will have to redo all the process. So the one that is going to take the time is it's going to have to create all of these vectors and spheres again. And what is the height again? I made it roughly 300. So let's make it the grid something big as 300. Okay, again, I'm gonna save just in case. Offset distance is used that this component is creating kind of a new surface on top of the geometry that is going to be the analysis on itself. This, in this case, the direct sun hours. That one I normally like to keep it fairly small. Let's make it something like 50. Legend parameters, you actually need to use a different component for that. You can leave it as default the legend component parameter if you change a few things, like for example, you also have it in here. Legend parameter is going to use the same component layer path, and you can change things like the size of the text or the color of those components and a few visualization things. You can slowly take the time to just hover on top of those and see what they do. When you connect that into this, it's going to change those into what you give it. But I like to leave it by default just to see what it gives me first, and then I decide if I want to change it. Parallel, this is a little bit complex to explain, so for now just leave it in the default. I recommend you to again go into online and try to search more specifically what all of those components that I'm going really briefly to what they mean, but just keep in mind it's optional. Finally, you need to give this one run option, change it into true or false. Oh, that's another one. This one you're going to use the Boolean toggle, so I can switch it between true and false. All right, save first, and let's change it into true. There you go. Now you can see the first analysis. And as I said, it's going to take all the information. As you can see, the faces of the levels that are facing the vectors are going to be brighter, which means it's going to be more intense, and the ones that are blue are the ones that are receiving the less amount of sun hours. And you'll actually get a little graph in here. This is the information that you can change with this legend parameter. Legend parameters. This is the information that you can edit. So you can say that the larger, smaller, vertical, horizontal, you can rotate those. If you give it a different point for the base, you can move around, text height, and so on. So you can change those things if you want to. Because I like to leave it by default, that I'm in here, I'm not actually visualizing that. I'm just using the data for the next part of our workshop that is going to be using Galapagos to ask the software to analyze the rotation of all of these flows to see what position is the best, so they receive the most or less amount of daylight. Okay, I think that's gonna be all for this tutorial, which I think is quite long and it has a lot of information for you to try. And remember, this is just the start. This is just the beginning of what Ladybug can do. So it's going to take you some experimenting with. But as you can see, is using really simple logic. That is, well, the first one, to get the information from the web, the weather information, EPW files. It's taking a lot of information in here, and you can just match what you have from one of the components to the next component. And all of this information, it will come handy for the different analysis. For example, radiation. It's gonna ask for different information when you go into, let's see, solar envelope. It's gonna ask for different information again. One that you can actually check, for example, is the windrows, and it will take more information like the wind direction, wind speed, comes handy for all the rest of the components. But it will be a matter of checking what it's asking you for and just matching the names. Like in this is wind direction, and you match it with wind direction. And be careful reading, be mindful of reading all the descriptions carefully. All of the information is in there. It's just a matter of how to match that data. Okay, For our case, used for the analysis of direct sun daylight incidence, we use an analysis period, just going from June to July 21 for the 21st, between the hours of 8 to 17, which is normally what you have for sun on that period. With that information, we created this sun path, and with that, I just, as an extra, I created this sphere, so it's easy to visualize where the sun is in that analysis. And I also plug this one to see the vectors, which is the direction of the sun in those different hours, just to visualize things a little bit better. And then I use the component again in analysis geometry, the first one that is direct sun hours. And from there, I again just plug it in the information that comes from the previous component, vectors to vectors, a few ones that can be left by default. And the geometry, which is the building that I'm analyzing, context. As you can see, the colors of this analysis are not going into anything that is plugged into the context. Is used as an extra option that it has. So all of the information is related to that. Grid size, just can keep in mind, is the resolution of this square. The smaller it is more precise, but it will take a lot more time for your computer to produce all of the information. So be mindful of that. Offset distance, just graphically where the colors of these colors are being placed in the surface of the building. And finally, a button to run the component. All right. Lots and lots to take in, I know. So take it slow, go back and forward with this video, and try it in your own time. Try it in your own Grasshopper file. Create your own geometry and try to see what happens if you use a different geometry, and see what you can do on your own. The logic is the same, and it will work the same for all the components. So try as well some of those components and see how it goes. All right. Thank you for joining in, and I'll see you in the next video.